const qualifier. The const qualifier is used to declare a variable whose value cannot be modified by the program. This ensures the data integrity and allows compiler to optimize the memory usage by placing the variable in read-only memory, so-called ROM. So const variable cannot be changed by the program or a programmer after initialization with a proper value. Hence, we can use it freely in the program as in expression or variable. For example, a const integer a is declared with the value 10. After assigning the 10 value, we cannot modify the value for the a variable anywhere in expressions, calculation, or we pass to the function, but still we can use further in our program execution. Specifically, the const qualifier is used when passing pointer to functions. It prevents the function from modifying the object being pointed to. Let's try to understand the same thing with example for passing and processing the string safely, as well as let's see incorrect usage. In this example, we have declared a const integer a with value 10 as a global variable. We are trying to modify the value for variable a in modify a function, as well as we have defined another function to add a dash in place of space. But it is important to note that string passed in the function as a parameter is considered as a const. Hence, during function execution, value for the string cannot be modified. Let's try to uncomment the line and see the error. As you can see, a red squiggly underline for a. If we hover the mouse, you can see expression must be a modified L value. Now, if we try to run the program, we will see compilation error. As you can see, the error is specifying the assignment for the read-only variable is not possible. Similarly, let's try to see the things for function as well. In this function, if we uncomment the line 20, then the same error will be visible during compilation. As you can see, the same error is available in the command line. Let's uncomment the line and run the program to see the output. The string is printed with the dash in place of space. Modify a function has no line for execution, hence our program runs successful. Let's go back and try to understand further in the documentation. Many of our library functions are using const in their parameter declaration to guarantee that arguments will not be modified during further execution, such as strlen helps to calculate the length of a string. Declaring str as const, ensuring function will not be able to alter the string. Important notes: const variables should be initialized explicitly, or it must be set by the hardware dependent means. For example, a reading a calibration constant from a fixed ROM address. Another embedded example, a memory mapped registers. The value for this all are completely dependent on hardwares. Hence, by declaring a variable as const, we are proving that any change to it will come from external events only. And by using const, we are improving the program safety, reliability, and readability. From this section, we understand how const prevents modification of variable and how consts are helping in function parameters to protect the data when it is passed by pointers. However, pass by value and reference we are going to see in future videos. And also we understood that in standard library functions, const are providing additional safety, and usage of the const is enforcing immutability and detect unintended modifications.